Hello, everyone, and welcome back to the Intro to C course, MCS 1142. Today is week 2B, which is the fourth session in total. It is the second session of the second week of semester summer 2021 at LTU. Today, and according to the syllabus, we are going over chapter 2, which is Introduction to C Programming. This chapter is where we start using Visual Studio for the basically majority of the session or majority of each session. I will basically be sharing my Visual Studio and typing code, building programs while explaining each of the topics of the book. After we are done today, you will be able to write simple C programs. You will be able to use basic input and output instructions and use different data types. You will learn about computer memory concepts, how data is stored in memory. In addition to those, you will learn arithmetic operations and the concept of precedence, order of precedence. And finally, a simple decision-making program, how to make a program that does or makes or takes makes a decision. So with that being said, I'm gonna go over and start. I'm gonna go ahead and start the session. I will start a new solution, new project from scratch. So as we learned, I'm gonna go over to create a new. I'm gonna create, I can just get it from here. So Windows Desktop Wizard. Next, I'm gonna say it is week 2B. I'm gonna dump it here. Place solution, yes. Next, I would like an empty project. Here it is. I would like it to be x64 debug. I'm gonna go ahead and add my first file, which is a CPP file, and I'm gonna call it main. In your case, for example, when you create a project for the homework, you go ahead and name this file your name and then the homework number, you save it, and then once you're done, you upload that file. So if I say add, now my file is here, imagine it has your name. Once you're done, you just go and say here, open folder in File Explorer, and then you're gonna find your file that needs to be uploaded right there. So what I would like to start with first is go again and build a simple Hello World application and go over each of the lines with some fancy additions. For example, I'm going to add the comment this time. So let me first write the complete program, and then we go over it line by line. So here I'm going to say simple Hello World program. Then I'm going to say date is 2021 2705. Then I'm going to say include stdio. Then I'm going to say int main open curly braces return 0 print f open parentheses open double quotation mark double quotations hello world semicolon. I'm gonna go ahead and say function main begins program execution here. Function main ends execution here. So starting point and ending point. So I'm gonna go over the lines 1 to 13. The first line is a comment. Notice I have two slashes at the beginning of the line. I don't have any slashes at the end of the line. Whenever I type two slashes at the beginning of the line, the compiler or the program will ignore anything after it. Anything after it, as long as it's on the same line. So if I go here and I hit enter and then I type anything, then this is no longer a comment. Why? Because it's not part of the line. So this is called line comment or commented line. I'm gonna go over the next type of comment, which is block comment. So notice at the beginning, I have a slash asterisk. This star character is called asterisk. Asterisk. This is what it's called, asterisk. So slash asterisk, and then I have my comment, and then at the end, I have the opposite of the beginning, which is asterisk slash. The difference between this and this one is that I can add new lines into this. As long as I am within these two delimiters, then everything in between is commented. So if I hit enter, it's still a comment. If I hit another enter, it's still a comment. So I can type anything here. All these are comments. Why? Because they are within the comment block. And notice the editor allows me to expand or collapse this block. So I'm gonna do it like it was and move on to line 3. So line 3 is a blank line. There is no characters, there is no spaces, it's a blank, complete blank. I can add spaces as much as I want. It will not make any difference. Or I can add tabs. It will not make any difference. So this line you can consider is gonna be ignored by the compiler. There is no code here, nothing to do here. So I'm gonna move on to the next line, which is line 4. Line 4 is called preprocessor directive or preprocessing directive. Preprocessor directive or preprocessing directive. So this line is always begin with a hash, with this simple, and it's processed by the preprocessor before compilation. So before the code is compiled, and I will go over in a second on the phases of compiling a code. So before the code is compiled, the preprocessor processes this line. This line tells the preprocessor to include the contents of this file into this program. So this header file .h.header, this header file contains information used by the compiler when compiling calls the standard input-output directory, such as this line. So since this line is calling a code from that file, so we would like to tell our compiler to include the content of this file into our program, because I'm using basically an instruction from that file. Again, it's a blank line. It's simply a blank line. You can use, as we said, space, space, tabs, or just keep it blank. It will be ignored. All these are called white spaces, whether it's a space or a tab. And we use them basically. You add these blank lines just to make the code more readable, right? Why? Because I can move this here, then I can move this here, then I can move this here, then I can move this here. Now this is a line comment, so I can't type anything after it. I have to go on the next line. So I can move this here, then I can move this here, then I can move this. Oh, I can't because it's a comment. So instead of having my program looking like this, I add blank lines. So I add one here, then I add two here, then I add another one here, then I add another here, another one, and here it is. So we add blank lines or white spaces just to make the code more readable. Then I move on to line 6. Line 6 says int main and two parentheses or empty argument list. This in between it is called argument list. In this case, it's an empty argument list. Nothing goes in between. For example, look at printf. It has one argument. Everything between this double quotation is an argument or a parameter or an input to this function. So printf takes this as an input and does something with it, right? It displays it on the screen. So it takes a value, it takes something and does something with it. In this case, main doesn't take anything. In our case, when we execute this function, we don't require any given. We don't require any input before we start. What is int? Int is the data type that main will return or produce at the end of the execution. In our case, we will just put 0. And then the word main is the name of this method, just like printf is the name of this method. So main is the name, this is the return type, and these are the argument list. This is called function definition, function header. Everything between the curly braces is the function body. So you have a function header and then you have a function body. Then I have a comment, blank, then I have a printf. Printf, F stands for formatted. And this is called an output statement. An output statement means it's a instruction or a statement that outputs stuff from my program to the outside world. In our case, to the screen, because it could be an output to the printer. It could be an output, some communication, output like stream something to another server. In our case, it's an output to the screen. This instruction tells the computer to perform an action, basically to print this sentence or group of characters. Now, notice this is called a string. In our language as a human, it's a sentence. In computer world, it's called a string. Everything between double quotations is what's going to be printed on the screen. So the double quotations are not going to be displayed on the screen, only the letters between these double quotations. This is called literal, means when you type a printf is different when you type anything between double quotations. Between double quotations is literally as is. So that's why it's called literal, because it's literal as is. Remember from last session, or you're gonna see later, I'm gonna have, as an example, I might have a placeholder or a variable called my variable equal 0. In this case, my variable is a placeholder that has the value 0. So if I tell printf, hey printf, I would like to display my variable, which is like this. So when I tell printf, hey printf, I would like to display a decimal, and I will go over these in details later, but the point I'm trying to explain is literal. When I tell it I would like to display my variable, printf is not gonna display m, y, v, is not gonna display the letters. It's gonna display the value that this placeholder is holding. In this case, it's 0. So when I execute this statement, it's gonna display 0 on the screen. On the other hand, anything between double quotations is literal, as is. So if I copy this and put it between double quotations, this is gonna be displayed literal. It's gonna display MYVARIABLE, is not gonna display 0. It's gonna display it literal as is. So I'm gonna go back to hello world, and by experience you can learn these when we go over the sessions for future. So this is a simple hello world. Now, notice how I said you double quotations are not gonna be displayed. So what if I want to display a double quotation? There are ways, and they are called escape sequences, and those are on page in the book. Let me go to chapter 2. It's page 42, list of escape sequences, figure 2.2. So while I'm talking, you should have your book open and you should have Visual Studio open. You should do what I'm doing in Visual Studio, and every time we are referring to the book, you open that page. Escape sequences. Notice you have \n, \t, \a, double backslashes, and backslash quotation. And there's a description for each, so I'm gonna run them right away. So what if I wanna display on the screen, literal, double quotation, hello world, double quotation. So if I go ahead and type 2 double quotations, this is gonna confuse the compiler. So the compiler is gonna be annoyed by the fact that, okay, printf is expecting one literal. So you gave me double quotation and then you gave me another double quotation. That means you're trying to display an empty. But what is this garbage after it? I don't know. The compiler is assuming like you gave it an empty string. The compiler is assuming that you did this. So you give me double quotation, then another double quotation. That means you want to display empty. So what is this garbage after it? In this case, we need to escape that rule. So we need to escape that rule that says double quotations do not get displayed on the screen. So in this case, I go from the figure 2.2, I go to the first one, sorry, last one, backslash between the, before the first one I would like to display and before the last one I would like to display. Now the compiler is gonna know, he's gonna know that the first double quotation and the last double quotations are the boundaries for the literal, and then having an escape sequence with double quotation will tell the compiler that, hey, display a double quotation on the screen. Same case for this, display a double quotation on the screen. So when I run this now, I'm gonna see double quotation, hello world, double quotation. So here it is with double quotations. Then from top to bottom on figure 2, there is a new line. So if I go ahead and type the letter N and another N and then display, it's gonna display it literal, N hello world N. But I meant to display a new line. So I say backslash, backslash. Let me, as a matter of fact, put 2. So N backslash, backslash N display. Now notice it's gonna display a literal new line, hello world, another new line, and then done execution. So this is one. Another one is tab. Backslash T is tab. Just like you see in Word documents, tab means like 3 spaces maybe or 4 spaces. So one tab, another tab, and then the literal tab, tab. The next one is A. A is for an alert. Alert means play a beep sound or an alert sound on the screen. So maybe you can hear it. Yep, did you hear it? That was an alert sound. Now it happens so fast that they sound once. All four will sound once because it's very fast. The next one is a backslash. So what if I want to display a backslash? So I go backslash, es escape that. Why we need to escape the backslash? Because imagine I have the word new. And I would like to display the backslash. If I type backslash new world, this will confuse the compiler. Why? Because backslash n is a new line, or backslash a is an alert, or a backslash t is a tab. So what if I actually want to display a backslash? Then I escape the backslash. So backslash hello world. If I want to type another backslash, then I escape it. So now it will display the actual backslash. So these are called escape sequences. Cool. Now I would like to go over what happens from this moment to this moment, seeing the output in front of me. There are six phases that get between writing a C program and execute and actually seeing the result or seeing the program running. Those six phases are, sorry. Those six phases are called edit, pre-process, compile, link, load, and execute. And they are in chapter 1 in page 15. So there is a diagram. I will go over the diagram really quick. So you have editor, preprocessor, compiler, linker, loader, and CPU. CPU means execution, basically. So loader and executing or executor. So phase 1. In phase 1, phase 1 consists basically of what you see in front of you. It's the editing. It's the process of editing the file, adding changes or removing changes or adding statements. And this is accomplished with an editor program. In this case, Visual Studio. Visual Studio is an IDE. One of its components is having an editor. And you type a C program with the editor, make corrections if necessary. Then once I edit, notice like if I add a letter, I have an asterisk here, then I save it. So now it's saved. So once you make corrections or you add your code, you save it to the secondary storage, in this case to the hard disk. Now every C program ends with .c. In our case, because we are not on a C IDE, we are on a C++ IDE. So in this case, it's C++. C++ will support C because it's based on it. So this is for phase 1. Then phase 2 is preprocessor. In phase 2, basically, you give the command to program. So when I click this, when I first click it, preprocessor starts. Preprocessing starts and then compiling and then linking and then loading. So this happens when I give, as a user or as a developer, I give the command to compile. Then the compiler will translate this C program to machine language. It goes and checks what are my settings and then what are the machines that I'm trying to target and translates it to a machine language code. What else happens in pre-process? In pre-processing phase, it goes and grabs all these lines that start with a hash, and then it includes them in this file. So it indicates that certain manipulation has to be performed on the program before compilation. So this, in instance, I have the compiler or the process has to go and grab content from this file before it compiles everything. Then we go to phase 3, which is compiling. Oh, sorry, hold on. Let me turn off my UPS. Okay. So in phase three is the compilation phase. In phase three, the compiler will basically translate the C program to machine language, similar to the phase before, but it will check for any syntax error. So a syntax error occurs when a compiler cannot understand a statement because this statement would not have the right language or the right grammar of the language. So if the compiler didn't recognize a statement because that statement violated the rules of the language, then it will pop a syntax error. So you will notice if I have a syntax error, which is like this, and I'm building, then I will reach a point where there is a syntax error. Syntax error means the compiler doesn't understand what do you mean by this. So it tells me, hey, don't show this, and no, I don't want to start all one. So this is the compilation part. Then we go to the linking part. The next phase is called linking part. In this linking part, it basically you see how this references a function in this. So, okay, in the compilation part and the pre-processing part, we went and grabbed content of this file and put it in one, let's say, jar or one bucket. So I have a program and preprocessor will put this program in the bucket and will grab all those included files, put them in one bucket. Now the linker is gonna go and map all these statements that are from the respective files and link them together. That's why it's called linking. Most used libraries are these libraries, like the standard libraries, and this is the job of a linker. Any missing pieces in your program will be linked or filled from the directive that you included. Then we go to the next um, phase, which is loader. Loader means, okay, now the linker is done, produced an object code and saved it on the hard disk. The loader will go to the hard disk or the secondary storage and load that code uh, into your program, into your basically like screen, into RAM. And then the CPU will execute it, which is the last phase. Execute that code or that object code. So this is a simple hello world with the process on how what happens between clicking and executing. Then I'm gonna move on with the lecture, which is writing a code for adding two integers, for example. So let me again type the code, and then we go over it line by line. So this is an empty program. I'm gonna say I would like an integer 1, integer 2. Then I'm gonna prompt the user to enter first integer, then I'm gonna scan from the screen into this variable. Then I'm gonna use the same, but in this case it's second integer 2, and then I'm gonna add them together. So I'm gonna prepare a placeholder, and then I'm gonna say this is equal to integer 1 plus integer 2. Then I'm gonna print it. So I'm gonna print f sum is whatever this is with the new line sum. So what am I doing here? Here I'm first line 8, I'm saying, hey program, I would like you to prepare a variable called integer 1. And that integer 1 is type integer. So this alias or this name or this placeholder holds a value of the type int, type integer. Then another one, also type integer, but this placeholder has a different alias, has a different name, and it's called integer2. Then I'm printing on the screen, printing a sentence, nothing else, just print a sentence, enter first integer. The next one is scanf. So I'm telling my program, after you print, I want you to scan. So after you write, I want you to read. I want you to read, and scanf takes two or more uh, parameters. In this case, it's taking two. One is the type that we are reading. In this case, it's a decimal. I'm reading a decimal. I would like to read a decimal, and I would like to put it in this placeholder. And this is the syntax. You have an ampersand and the name. Then I'm doing the same for a second integer. So I'm telling it, write this, then read a decimal and put it in integer 2. Then I'm telling my program, prepare a placeholder called sum, also of the type integer. Then this sum is equal to this placeholder plus this placeholder, meaning grab the value that is stored in this variable, add it to this, so from right to left, and grab the value that is in this variable, add it to the value of this variable, then assign it to this variable. So the result of this operation will be assigned to this variable. And then I'm printing, I'm telling printf, I would like you to print this literal whenever you have a ampersand, whenever you have a percentage d, means replace these two characters with whatever value I'm giving you. And this is basically a syntax. This is when I meant programming is like riding a bicycle or writing a guitar. There is no way you figure these out. These are experience. In experience, you memorize this. You memorize that printf does this, and I give it a substitute to substitute these characters with these. So even if you read it in the book, once you start typing the code, you forget about it. So this comes with experience. I'm gonna go and execute. Oh, I know what this is. We need to use scanfs for now and start. So enter the first integer, I'm gonna say 5. Enter the second integer, I'm gonna say 10. Sum is 15. So this is my first program, my humble calculator. Sweet. Sum is 15, enter. So this is a program to sum two integers. If you have any questions, shoot me an email. So the next topic in the book is arithmetic operators. So arithmetic operators means this. Arithmetic operators we have, I'm gonna remove this. I'm gonna put a block. So what are our arithmetic operators? We have a plus, negative, subtraction, multiplication, and remainder. This percentage is called remainder. It's not like percentage like per 100. It's called the remainder. So what is remain, or let me start with the addition. So addition meaning you have two variables like before, integer equal, for example, this one is equal 10, and my integer 2 equal 15. If I say int sum equal my integer 1 plus my integer 2, as we've seen before, I'm executing an addition operation. I'm adding these two to each other and then assigning them to the variable sum. Um, this is addition. Then I have a subtraction. Subtraction meaning I am subtracting one from the other. So if I say negative, meaning minus my integer 1, negative, or subtract the value of my integer 2, and the result of this operation will be assigned to the sum. Then I have division. Division, same case. Grab this value and divide it by this value. Now notice if I do this, it's an error because I can't divide by 0. See how it was runtime error? Integer division by 0. You cannot do that. System will crash. And this is called logical error. And we will go over errors soon, like the different errors. Multiplication. Multiplication means grab one of the values and multiply them with the next value. Remainder. Remainder means I have a number, remainder another number, result into that variable. Meaning, if I have 10 and then another number would be, let's say, less than that, so 3. 10 remainder 3 is 1. Why? Because if I take all the 3s from the 10, what am I left with? So 10, how many 3s is in 10? There is 1, 2, 3. Then I'm left with 1. I cannot take 3 out of the 1, so this is the remainder. So the remainder is 10 over 3, and the remainder is the leftover, the first number over divided by the second number, not in a decimal. So if I want to put it in a sentence, remainder is the leftover of is the integer, right? Integer, it's a number, not a decimal. So integer leftover of one number subtracted, divided by another number. So this is the remainder. In this case, sum is 1. Why? 10 remainder 3 is 1. If I remove all the 3s from the 10, I'm left out with 1. So these are called arithmetic operators. Okay. Now, if I have all operators on the same, if I have multiple operators in the same line, or for example, I have like this. So sum is 1 plus 5 minus 7 plus 2, or multiply by 2, divide by 5, plus 3. So I have this. In algebra, multiplication is an X, but not in programming. And in an algebra, there is an order of precedence. Order of precedence means there are some operations that should be executed first before the rest. In this case, these 3 have a higher precedence. So these 3 will always execute first, and then these 2. Now, in case I have multiple same precedence operators, for example, I have multiplication and subtraction. These 2 are on the same level. In this case, it's gonna always start from left to right. So it will always start 7 times 2, and the result of this will be divided by 5. So from left to right. Same case for the rest. With plus and subtraction, if I have multiple ones in the same statement, it starts from left to right. So it will start with 1 plus 5, then the result is 6, then 6 minus 7, the result is minus 7, then the rest. So in this case, the execution of this program would be something like this. It's gonna be first thing first. So 7 multiplied by 2 is first, because left to right on higher precedence. Multiplication and Subdivide division is higher precedence. So first one is this, then this, then this, then the result of this will be subtracted from the result of that, then the result of everything will be added to 3. So in the exam, you're going to see something like this. Hey, what is the output of this statement? Then you need to know which one executes first. Okay, so this is called order of precedence and arithmetic operators. Now, next thing you need to know is memory concept. So in memory, when you say int my integer equal 10, the operating system will go and allocate a memory slot for you. Let me open Paint. So you know how in memory you have space, you have a space, you have slots, like a parking lot. So when you tell your program, I would like an int and give it this name, then this value, the operating system will go give you a space for an integer, which is 4 bytes. And we're going to go over the size of each type. Not this one, where is it here? So let's say the operating system gave me this slot. So the operating system will give this slot name, which is my integer 1, and will put a value inside it. So now in memory, I have a memory slot that has the value. What was my value? 10. It has a value of 10 and is assigned to my integer. So my integer 1 is pointing at this address, and this address has the value 10 in it. So it's done with this statement. Then it goes to the next statement. Int my integer 2 is a 3. So the operating system will go to a new available slot. It will go and look up where is any available spot. It will find a 1. It will put 5 in it, and then it will assign it to my integer 2, so on, so forth. Now, what is the size of this slot? We will discuss this later. But for now, imagine it like this. Anytime you create a variable, you are basically allocating a memory address to your program and putting a value in that memory. This goes back to the scanf. So if I go back all the way to scanf, you see this syntax, ampersand my integer. This is telling scanf to read a value from the screen and put it in this address. When you say ampersand and the name of your variable, meaning the address of this variable, and we will discuss this later. Now I'm gonna stop here for this session. We still need to do decision making and called relational operators, which is very small topic, just like arithmetic operators. It's a bunch of operators that you need to learn about, and it means it takes operands, right? It's an operator, takes operands, and called relational operators because it is evaluating the relation of one variable to the other. So integer 1 and integer 2. There is greater than, less than, greater or equal, less than or equal, they are equal or not equal. So those are relational operators. So we're going to see them in action and how to take actions based on the evaluation. For example, read two integers, and then if integer 1 is greater than integer 2, tell the user integer 1 is greater. Or if integer 2 is greater than integer 1, then tell the user integer 2 is greater than, is the bigger one. Or if they are equal, tell the user they are equal. And if that's it, basically. So we're going to see them working. That's it for this session. I'm going to display, I'm gonna go over the homework really quick, which is gonna be displayed today. The homework is this, just like what we did. I want you to build a program that does the following. It takes two integers from the user, and then it displays the sum of the integers, displays the subtraction of the first integer from the second integer, and then displays the multiplication of the integers. And I gave you an example. Once you're done, I need you to comment each of the lines and then upload your CPP file. Oh, it says zip. This is wrong. It should be CPP. So you go to your program, you say open folder, and then you grab this file, copy it, paste it in your desktop, and then go to Canvas, upload this file. Okay, good luck, and let me know if you have any questions.